Hi everyone, it's Coach K. Today we're going to measure and construct segments, lesson 1.2. The first thing we're going to do is we're going to do the ruler postulate, as you can see over here. We're going to be using the absolute value. Remember, the absolute value is the distance away from 0. So what we're going to do is we're going to use this formula, x2 and minus x1, and we're going to look over here. So what is A, or A to D? So A is a -3, D is 5. Which one is bigger? Okay, so right here, you're going to do 5 minus, so we're using that absolute value, a -3. A negative and negative make a +3. So the absolute value of that, 5 plus 3 is 8. Remember, if anything is inside of the absolute value, doesn't matter if it's positive or negative, it's always going to come out a positive. So our answer is 8. So let's look at number 2. Number 2 is C to B. C is right here, 4, minus B, which is right here, 1, and we're going to take the absolute value of it. So 4 minus 1 is 3. The absolute value of 3 is 3. Now, what happens if we switch that around? What happens if we switched it to, which you can, 1 minus 4? So that gives me -3. The absolute value of a -3 is +3. Every time it comes out of the absolute value sign, it's always going to be positive. Doesn't matter if it is negative on the inside, but it's always going to be positive. So right here, let's do the last one. Absolute value of 1,634 minus 7. When I subtract that, that gives me 1,627. The absolute value of that is 1,627. All right, the next part that we're going to be doing is the segment addition postulate. The first thing we're going to discuss is point B is between points. So we look over here at our diagram. Here's our point B. What is it between? It's in between A and C. Now remember, in between does not necessarily mean the midpoint, but it can be the midpoint. So then what do I notice? I know that the distance from A to B, okay, then you have the distance from B to C, that ends up becoming A to C. So how we're going to say it is, we're going to say part plus part equals whole. So we have P plus P equals W. So when we're working it out. So let's look at the very first one, number 4. We're trying to find D to F. So we're trying to find the whole thing from here to here. So yes, I know that you can do it quicker, but we need you to know the process because not every time you're just going to add them like we're going to do here. So the process is you have part plus part equals whole. What is your first part? Your first part is line segment D to E. Plus, what's your second part? E to F equals, what's the whole thing? D to F. So now, what is D to E? D to E is 23. That's our first part. E to F is 35. And then we're trying to solve for D to F. So when I combine these two, which is 58, equals D to F. All right, so on problem number 5, let's do the same thing. We're going to start with part plus part equals whole. Our first part is x to y. My second part is y to z. My third part The whole thing is x to z. So what is x to y? 3a plus second part 14 equals 41. So when I combine like terms here, oh wait, it's a two-step equation. I need to do the inverse, so I'm going to subtract 14 on both sides. So I have 3a equals 27. And then I'm going to divide by 3 because the inverse operations of multiplication is division. Okay, so I have a equals 9. Ooh, 9. Okay, then what is it asking for? It's asking for x to y. Okay, so it's not asking for a, so we got to go to that next step. So x to y equals 3a. We know that 3 is there, a is 9, 3 times 9 is 27. So x to y is 27. All right, so let's do problem number 6. Number 6 says, points P, Q, R are collinear. Remember, collinear makes a line with points Q between P and R. So let's draw that out. So now, remember, Q is between. It's not the middle. It just says it's in between, so it can be anywhere in between. Q to P is 4x minus 20. Q to R is 2x plus 30. And the whole thing from here to here is 100. So we're still going to use what we just did just a second ago. So we have part plus part equals whole. My first part is P to Q. My second part is Q to R. My whole thing is P to R. Now, do you need to write this statement all the time? No, but we need to make sure that you understand it because that has been on the different district checkpoints and the SAT. So let's substitute in. Let's put in first part is 4x minus 20. The second part is, keep your adding, 2x plus 30. And then the whole thing equals 100. So remember, what's the first thing you do? Combine like terms. So we're going to combine like terms. So we're going to combine our x's together. Don't forget your sign. So that gives me 6x. And then I'm going to combine my numbers. So I have a negative 20 and a positive 30. So that gives me a positive 10. Because remember, you subtract them and keep the sign of the larger. Equals 100. Now, inverse operations for addition. So I'm going to subtract 10 on both sides. That gives me 6x equals 90. Then I'm going to divide by 6 because inverse operations for multiplication is division. So when I divide, x equals 15. So is that what we're trying to solve for? We're just trying to solve for Q to R. Okay, what is Q to R? Q to R is 2x plus 30. So we have to substitute back in. So I have 2 times 15 plus 30. So I have 30 plus 30 equals 60. So my answer would be 60. All right, so we're going to talk about congruent segments. Congruent means equal to. Okay, is congruent to is almost the same as equal to. There's a slight difference between the two. So if I'm looking at these, as you notice, there's a hash mark here and a hash mark here. It's saying that the two segments are congruent to each other because they're segments. Segments are congruent. Lengths are equal. So if you have the number 5 for the top one, 5 has to equal CD also. So that means this is 5. If their segments are congruent, you're just comparing the two. So there's a big difference between an equal sign and a congruent sign. So we're going to discuss the distance formula. There's a formula for it, but if you know the easier way to do it, you can also do it that way. Ask your teacher for the easier way. So right here is my distance formula. So what do you notice? You have points there. X2 minus x1 squared plus y2 minus y1 squared. So let's look at problem number 7. So this is my x1 and my y1, and then I have my x2 and my y2. So we're going to use that formula that we have up there and substitute into it. So I have my square root, and then I have, what is my x2? x2 is 4. So I'm going to put my 4, my minus stays the same, and then I'm going to my x1. My x1 is a negative 3. A negative and negative make a positive 3. And then you still have squared plus, then I'm going to do my y's now. My y2 is a negative 1 minus my y1, which is a negative 2. A negative negative make a positive 2. And then you have squared. So combine these two. 4 plus 1 is, 4 plus 3 is 7. So that's 7 squared. I have a negative 1 plus 2, which is 1 squared. So 4 squared is 49. 1. So remember, you still have the square root symbol going on here. And so I have the square root of 50. That's not a perfect square, so put in your calculator and you get 7.07. All right, let's do problem number 8. We're going to use the distance formula again. So this time we need to figure out what are our points. Our points are V, which is, start at your origin, negative 2. So that's a negative 2. And I'm going to go up 1, 1. So there's my V point. Okay, so we need the W point, which is, start at the origin, positive 5. And then we're going to go down, so that means that's a negative 3. All right, so let's substitute in and then put all these good stuff into the distance formula. Remember, here's your x1, y1. Then we have our x2, y2. So let's do the distance formula. The distance formula is my x2. My x2 is 5 minus my x1, which is a negative 2. A negative and negative make a positive, so we have a positive 2 squared. Then we have plus, and then I have my y2, which is a negative 3, plus or minus, and then I have my y1, which is 1, and then I have squared. So now let's combine like terms. So 5 plus 2 is 7 squared. Negative 3 minus 1, which is a negative 4 squared. So that gives me 49 plus 4 times 4 is 16. Negative and negative make a positive, because remember, this goes to both of them, not just the 4. Goes to both of them. So we're going to add it. Combine like terms. Remember, all of these are radicals. So this is a radical 65. And then put in your calculator and you get 8.06. All right, that's the end of our lesson for today. Have a great day.